Draw the region of the Argand diagram for which these two loci are satisfied. I'm going to deal with the left-hand one to start with. This is going to be a circle. Okay, I'm just going to talk a little bit about y. So we've got x minus 3 plus y minus 4i. That's how I can write that z, because z is actually x plus iy. And this is less than or equal to 5. Remember, to get the magnitude of a complex number, let's just set it equal for the moment, actually. Then we'll bring the less than back in. So to get the magnitude, we'll use Pythagoras' theorem. It will be x minus 3 squared plus, ignore the y, plus y minus 4 squared is equal to 5 squared. And there we go, there's our circle. So center is 3, 4. We're just doing a sketch. Maybe it's about here. Radius 5. Now, one thing to notice is it's going to go below this axis. It's going to go to the left of the y-axis. I should probably say it's the real and imaginary, actually. And that is x and y. But here's the thing, 3 squared plus 4 squared is actually 5 squared. So it's going to go through the origin. You must make sure that it does. It's also going to bring it down the page a little bit. So there we go. Now the less than or equal to, if I make my circle less than or equal to 5 squared, then I'm sort of saying it's all the points that are lower than the radius. So it's going to be inside the circle. So in a bit, we're going to shade that. But I'm now going to move on to the modulus of z less than or equal to modulus of z minus 2. Let me first of all look at if that's equal. Now this is one to just remember, it's the perpendicular bisector between the points. So we've got 0, there's no imaginary part here, and we've got 2. Remember the center was 3, 4, so it's got to be to the left of that. Then it's going to be a vertical line halfway in between. Let's talk about why that one is. Oh, sorry, it's not quite vertical. Okay. So let's talk about why that is. The modulus of z is the distance away from the origin, and the modulus of z minus 2 is the distance away from 2. So that's why it's going to be the perpendicular bisector. It's all the points that are exactly the same distance away. You can also show it algebraically. So it would be x plus iy modulus is equal to x minus 2 plus iy modulus. And just like for the circle, like how I got the x minus 3 squared, I can do the same here to get the magnitude. It's going to be x squared plus y squared equals x minus 2 squared plus y squared. They cancel. This expands to x minus 4x plus 4x. Now the x squared minus 4x plus 4, sorry. The x squareds cancel, doing a bit too fast. Then 4x equals 4, x equals 1. You can see we get the perpendicular bisector, and you can prove it in general. I'm just trying to give you different ways to remember it and understand it. So now, right, let me draw it a little bit further up. Okay, I need to get the loci inside the circle, and then because the modulus of z is less than or equal to z minus 2, it's actually got to be closer to 0 than to 2. So it's actually going to be inside the circle, but to the left of the line. Another way you can do it is to pick a point. We could pick 0, 0, and then this would be 0, and this here would be the magnitude of minus 2, it would be 2. So that's, we can see that 0, 0 is in the region the modulus of z is less than or equal to the modulus of z minus 2. Whereas if you picked a bigger point over here, then it wouldn't be. So finally, let's shade to the left of the line inside the circle. And you don't just stop here. We're going to keep going. The axes don't really have any bearing on it. They just give us a kind of a visual for where 0 is. That is going to, also down here, that is going to be the sketch on the Argand diagram that satisfies these two inequalities.